First of all, thank you so much for being here. I've been following your work for many years, and I immensely hugely enjoyed your books, and I listened to many of your podcasts and interviews that you've given. So just a huge pleasure for me to be speaking with you here
Oh,
today.
well, very welcome. It's a real
Um,
pleasure to talk to you.
yeah, and I come from Ukraine, and as you know. Like when I was reaching out to you via email, and I was uh, sharing my thoughts about the situation in my home country, and like I remember, and then I've noticed also that like your middle name is Victor, right? So it goes full name Harry Victor Cliff, and
Yeah.
I was curious, like if you could tell us a little bit about the origins of that. If was it like the name of your grandfather? Because you also mentioned in your email that your grandfather was from Lviv. So
Yeah, that's right. Yeah,
just
so
yeah.
Victor, yeah, it's my grandfather on my mother's side's name. So he was Victor, but he was Polish, so it would have been spelt with a W. So like Wiktor. But when I was born, my parents anglicized it to Victor. But yeah, he was from Lviv, or Lviv as it was in the because he was born in the 1890s, so very long time ago. At a time when Poland didn't exist because it was partitioned between the Austro-Hungarian Empire, Prussia, and Russia. So he had a very long, complicated life, but he was in the army, the Polish army in the Second World War, and then when Poland was invaded, he ended up escaping and eventually making his way to Britain. So that was sort of so yeah, I mean, Lviv is somewhere I've always been. My mum particularly and I have both been quite keen to visit, and well, maybe not right now, but I hope in the future we'll actually get to go and see because I never met him. He died in 1969, long before I was born, but he used to talk to my mum a lot about Lviv and what a beautiful city it was, and he used to say that when he slept at night in his dreams, he walked through the streets and obviously sort of felt very homesick for this place that he couldn't return to. So yeah, I hope in better times we'll be able to come and visit you in Ukraine and see the city.
Yeah, just amazing to me. And my dad's name is also Victor. So
Oh, okay, okay.
yeah. And just amazing, that you have this connection with my country, like, and historically, like, even though you're now thousands of like miles away from, so yeah,
Yeah,
from
yeah.
Ukraine. And I'm also like feeling a little bit jealous, speaking to you because, well, how can I say it? Well, let me back up a little bit. You know, for, I love learning about like science's history, like going all the way back to like Newton, Galileo, this like fathers, obviously, of modern science, modern physics, and uh, like the country that you live in, England. It's just it's got so much history in it, especially when it comes to like science history, and obviously the University of Cambridge, right, where you're based at and where you work, also like so many brilliant like scientists throughout history have been like professors and students there. Folks like Newton, Hawking, like Niels Bohr, and I guess Oppenheimer also studied, yeah, at Cambridge, if I'm
Mhm.
not mistaken. So just you know, I'm just curious, like, do you feel that sense of like tremendous scientific legacy when you, for example, walk into a room at Cambridge University, or like I guess not now, it's more like it's become routine, right? You just go go to work and do your job, but maybe one of the first times when that that you went there, maybe uh, you remember maybe you could share about what that was like, that kind of experience.
Yeah, I mean,
It's
you're definitely aware of it. I mean, in fact, some part of my job at the Cavendish laboratory, which is the physics department at Cambridge, is I look after this historic collection of scientific instruments. So we have this museum in the building that goes back to the founding of the lab in the 1870s, and it has the tube that discovered the electron and part of the particle accelerator that split the atom and all these other amazing things. So there is definitely the sense of history. But I think one thing to say about Cambridge it's not as if all these scientists came from Cambridge, but a lot of them came from other places. So Rutherford, for example, who did so much work on the structure of the atom and the nucleus, he was from the other side of the world. He was from New Zealand. Um, and I thinking actually when I was writing my first book, so there's a very important figure from Ukraine in that, which is George Gamov, who you may be aware of, who's one of the fathers of the Big Bang theory. He was from Odessa originally. So in the era of the Soviet Union. So but I mean there is a sense of history. I think in Cambridge though, we're just moving into this new laboratory which has just been finished. So it's not like we're sitting in this kind of like a neo-Gothic museum. It doesn't really feel like you're sort of too rooted in the history, and like the research that we do has moved on a long way from 100 years ago. But nonetheless, yeah, it is exciting to think you can walk through the same corridors as people like Rutherford and Maxwell and even Newton, going back even further for sure.
And I'm always interested in like people's origins. Have someone that ended up where they are today, and would you say that would you trace your obvious love and fascination with science and physics in particular back to your childhood? Maybe you had a particular experience in your childhood where you went like, oh my God, I want to study the universe, and or maybe if you could remember someone who's had like a big singular impact on what you ended up doing in life, maybe some teacher or one of your parents.
Yeah, I mean, I think it probably comes from my parents to a large extent. They both did a science subject at university. So my mum did chemistry at Edinburgh, and my dad was also at Cambridge back in the 70s. And he started off thinking he would do physics, but then he made friends with loads of English students, like as in English language students, and he ended up doing history and philosophy of science instead. So he kind of like put physics, he sort of said, was too hard, and physicists didn't have any fun, so he thought he'd try and do something a bit more like arty, basically. But yeah, they both had scientific backgrounds, and I think when I was a kid, they encouraged me and were ready to ask or answer all my sort of silly questions that I would ask them regularly. So I think I was always very interested in science and physics and chemistry and astronomy. And I think even at primary school, I was one of those really annoying kids. I remember that we had this lesson when we were about 10 years old where a teacher was explaining about light and how light travels in straight lines. And he got us all to draw a straight line with an arrow on it. And I put my hand up, and it must have been an insufferable little swat, and said, "Oh, actually, sir, sometimes light bends, when it goes past like the sun or like really massive bodies." Because my dad had taught me a little bit about Einstein's theory of general relativity, this idea that space is bent and light doesn't always travel in straight lines. And the teachers were just, "Shut up, Harry! You're just confusing the others. We don't want to hear about that." So I think, I was always interested. There isn't a single moment that inspired me as such, but I think it was throughout my education. There were a couple of teachers that stood out. I had one physics teacher called Mr. Haythorne, who was really great when I was at secondary school. But actually, a lot of physics teaching, I don't know if this is true in your experience or in the listener's experience, but a lot of physics teaching is quite bad often. But there were a few occasional figures who inspired you, but you had to kind of soldier through quite a lot of like pretty boring or badly delivered lessons. But the thing that appealed to me about physics was that it kind of revealed this secret truth about nature that actually, the world isn't really how it seems, that when you go down deep, all the things that we're familiar with, they don't really exist, and they all emerge from these much more fundamental, more mysterious basic ingredients. And the fact that you can make sense of the world through this very small number of simple ingredients was really, really appealing. And that's why I fell in love with the subject. And it was really a process just going through my education. And then when you get to university, you discover physics is a whole new subject, which is much, much more mathematical, and it's much more about problem solving and reasoning in a way where at school, maybe it's a little bit more about learning facts and doing certain experiments. And that becomes very, very satisfying. So yeah, I think it's a sort of mixture of all these different influences, teachers, but just the sort of subject itself and reading popular science books and watching documentaries, they were a big part of what inspired me when I was younger as well. They played a big role.
And for me, it was in my own experience, it was reading a lot about again, great scientists like Einstein and Hawking, and obviously I got really moved and inspired, like many did, by Hawking's life story. And I remember also like being so upset when I found out that he died, and like it was like because he's been just a huge source of inspiration, not just for me, but like to millions of people. And I'm also like wondering if you um, have you had like the chance to interact with him personally at all, to meet him maybe while in Cambridge, or no? I'm just curious.
Yeah, so I sort of encountered him a few times. First of all, when I was an undergraduate at the college I was part. So in Cambridge University, as a student, you're assigned to a college, which is a bit like an old religious institution in a way, but they're basically like these kind of communities with their own buildings. They're kind of separate mini universities within the university almost, and that's where a lot of your teaching happens. It's where you live, it's where you have dinner. And every evening it's a bit like Harry Potter. You have this big meal in an oak-beamed hall with long tables. And at the end of the hall, there's a high table where all the fellows, so the senior members of the college, the professors sit. And Stephen Hawking was a member of the college, so you quite often see him at dinner. Sometimes you see him like trundling through the courtyards, like in his wheelchair. And he had quite sort of mischievous sense of humor. He used to try to run undergraduates over when he saw them. He'd kind of accelerate towards you. So that was my first like brush with him, although I never really spoke to him, because he was in the maths department actually, and like a very theoretical physicist, whereas I was studying at the Cavendish, which is the experimental side of things. But later on in life, I kind of came across him a couple of times. One in particular at the Science Museum. For many years, I was a curator at the Science Museum in London. And one day, I got a call from our director of communications saying, can you come downstairs to the, like, what they call the fellows room, which is kind of like a fancy room where the fun people who give money to the museum can kind of have a cup of tea, basically. And he said Stephen Hawking is visited with his grandchildren. So he turned up with some of his children and his grandchildren. And they were he wanted to go onto the gallery. So the Science Museum is a big museum in the middle of London, thousands of people milling around. And the museum knew that if they let Stephen Hawking go out into the gallery, it was going to cause pandemonium. So they wanted to have some people on hand to kind of manage it. So anyway, while they were doing all of that, they asked me to come down and talk to him because Harry's a physicist. He could like talk to Stephen Hawking. So I was kind of put in front of him and just sort of started saying, nice to meet you, Stephen. I was actually I'm at Cambridge as well, and blah, blah, blah. But of course, it takes him quite a long time to respond because he has to sort of select responses almost word by word using this screen. It's very slow. So he's just sort of sitting there staring at you. And I kind of got this sense that he sort of was thinking, who is this idiot that they've put in front of me? So I just kind of gabbled away for a bit. And then eventually his family turned up and I was kind of saved from kind of embarrassing myself. So yeah, I had a few encounters with him, and he was like, obviously an inspirational figure, just in his own right as a scientist, but obviously particularly given the physical challenges he had to overcome as well.
Yeah, and so you've written two popular science books, right? So one is How to Make an Apple Pie from Scratch, like your first popular science book, which came out a few years ago, and your latest one. It's the one actually that I see behind you on your show. Yeah,
I get the copy.
Yeah.
So yeah, here they are.
Yeah,
these are the UK editions. So yeah, that was the first one. Came out back in 2021.
Yeah,
and this is the new one. Yeah.
And so the first one, it's using Carl Sagan's famous quote. Yeah, have to make that he came up with. And so there's this very famous phenomena you might have heard of it. When it comes to like science communication, the so-called curse of knowledge problem. That essentially when you understand something like very deeply, you sometimes forget what it's like to hear it for the first time, and you may not talk in the language that the layperson would be able to understand, because you just assume that that they will be able to follow you. And I'm just wondering if you maybe if you have a particular strategy for bringing this like obviously very complicated and ideas from from cutting edge research out to the general public. because sometimes it can be quite difficult for people to follow. I mean, like you do a beautiful job of it, and I can say this like from having read the top few books, but still maybe I was wondering if you have maybe some thought process behind writing popular science that that you might share, like how you go about doing it. Yeah.
Yeah, it's interesting. I've been asked this question a few times. I never really have a very good answer because I think I'm not a very reflective. I'm not very reflective when it comes to the way I communicate. I think it's sort of natural to an extent, and maybe it's because I think to understand, for me to understand something, I have to break it down into a series of simple steps. So it's a kind of expression of, I suppose, the way I think to a certain degree. But I mean, another thing, I think what I always try and do, I think, popular science isn't just about presenting the science. It's about presenting the sort of this process of scientific discovery. So storytelling is a very important thing, I think, at least in my writing. And my books, I try to make them into sort of almost, mystery stories. It's about this kind of process of discovery and the people involved and the journeys they go on and the challenges they face. And that's what makes, I think, science exciting. It's not, and physics particularly, it's not about just presenting some stark facts like, these are the 17 particles that make up the universe and these are the forces. You can say that in a page or two, but what's exciting about physics is how we figure out these things about the world and this process that we apply to the world. So most of these books are really about that process and how we go from sort of not understanding something to understanding something, or realizing that the way we thought about the world was completely wrong and it's actually totally different than what we thought. And I think that's what is sort of magical and exciting about science. It's that process and it's very dramatic. I think the stories in science are really dramatic and inspiring. And I suppose, you mentioned Oppenheimer briefly a second ago, that film, for example, by Christopher Nolan that came out last year, that whole story is a brilliant example of the scientific process, and in a particular story that not only has huge scientific consequences, but huge political, geopolitical consequences as well. And that's what I love and find exciting. So I think those are the stories I try and share. I very rarely give a talk or write an article that is just explaining a concept. It will always be centered around a person or a group of people and the journey that they go on. And I think that helps ground it because, that's ultimately, I think, as a reader or someone listening to a talk, if you're taken along on that journey with the scientists, you can kind of feel the same excitement at the moment of revelation and so on that they have. And that makes the whole thing much more compelling. And then it makes you care enough to do the hard work to actually understand what can be quite difficult scientific concepts. But I suppose the other thing I would say, it's actually like, although physics, is regarded as being a very difficult subject, and it is in a way, most of it, if you can take the most complicated idea, you can break it down into a series of steps, and each of those steps on its own is quite simple. And so it is possible, actually, even, in a book like these, for example, you can take the audience quite a long way, as long as you are aware of the things they don't know and be sure to explain them properly. And, if you're methodical, you can get people to understand quite a lot, I think.
Yeah, and I read somewhere that physics, it may appear very difficult because we know so much about it, but it doesn't mean like it's not like impossible, or it doesn't mean that it's for the layperson it's impossible to understand. Whereas, for example, if we talk about the issue of consciousness or something like this, where we know so little, it's different, but in a very different. It's difficult, but in a very different kind of way. At least
Yeah.
it seems to me like this. But it's actually. I'd like to pick up on what we were just saying about like the scientific process, and I had to say that I had never really been exposed to this way of looking at science. As a kid, when I was just in school, like you said, in school the experience of that most kids have of science is actually quite, they view it as this very boring subject, like very intimidating and so on. And but it was like only after I got out of school, and only when I was exposed to books like yours, and like Brian Cox. I'm sure you know about him, yeah. And when it's people like that, that I really begin to view it as like you said, this quest, this journey that we've been on to to figure out the like all this, like the answers to these big questions of existence basically. And it's for me it just goes completely against this kind of a common stereotype, this perception that many people like in the general public might have about scientists. They view scientists as this like very boring, completely devoid of uh, any passion or excitement for people. And for example, when I'm listening to one of your talks, or when I'm just speaking to you right now, like I love that you have this smile on your face when talking about the stuff. Like clearly, you're excited about it, and just for me, it goes against that public like perception that many might have about scientists and science itself. Like they view it as this like lifeless and yeah, very boring subject that you have to do in school, but then you sort of leave it behind. Maybe I don't know if you can maybe say a few words about that. Maybe you've encountered people in your life who had this kind of perception about science or scientists.
Yeah, I think that is probably quite common. There's a great story by Feynman, which he tells in an interview for the BBC back in the 1980s. So Richard Feynman, who's one of the sort of leading theoreticians of the 20th century and established a lot of the theory behind our modern understanding of particle physics. And he talks about in this interview a conversation with an artist, and the artist says to him, oh, you scientists, when you look at a flower, you can't appreciate the beauty of the flower. All you want to do is take the flower apart and dismantle it and kind of pick it apart and understand what's going on. And Feynman sort of says, in his kind of like New York drawl, like, well, I may not have as, refined appreciation of beauty as you do, but, when I look at the flower, I can see its beauty, but I can also see that, the colors it has were evolved over millions of years to attract insects and the structure of the stamen to disperse pollen. And he says, I don't see how that understanding detracts from the appreciation of the beauty of the flower. It only adds to it. So I think there is this sense that science is this sort of sterile, dry subject, or that scientists are boring, as you put it. I mean, I think, there are these stereotypes about physicists, and some of them are justified to an extent. I probably shouldn't say this, but if you meet a bunch of physicists, some of them will seem, very normal and sort of jolly and interesting, but some of them are quite kind of focused on what they're doing and head down and maybe a bit socially awkward. But there's a spread. I think if you look at things like The Big Bang Theory, the TV show, where you have like Sheldon Cooper, who's probably the people's idea of the archetypical physicist, and I've definitely met people like that. Those people exist to an extent, but most people are not like that. Most people are pretty ordinary, and yeah, it's a perception I think that has shifted a lot in the last few decades, thanks to people like Brian Cox and Neil deGrasse Tyson and others around the world. And I don't know what the situation. I don't know who in Ukraine are your kind of public figures in science, whether the same thing is happening there or what. But I'm hoping that as science, I think also this is a democratization of science communication. You've got science YouTubers who are doing great work, who have big followings, who's that a lot of that is also based around a certain personality, that they've kind of got this friendly, inviting, enthusiastic persona, which hopes to hopefully kind of remove this stereotype. But though, as I said, the stereotypes are true to an extent sometimes as well.
Yeah, no, I love watching Veritasium, for example. I'm sure yeah, and he's got I guess that's the name of it. Derek Mueller, I guess that's his name. Like he talks a lot about physics, this yeah, and has millions of subscribers. And well, I also want to ask you, like, what kind of work are you involved in now? I read that you're involved in something like the LHCb experiment, right? The LHC stands for the Large Hadron Collider, and B is for one of the porks, and maybe like if you could say in few words, like what's that about? That kind
Yeah,
of
so so the Large Hadron Collider is a gigantic particle accelerator buried 100 meters underground at CERN near Geneva, which is the European Organization for Nuclear Research. And so it's this big ring. It accelerates subatomic particles called protons to almost the speed of light, and then it collides them into each other. And I work around this 27-kilometer ring. There are 4 places where these particles collide, and around those points there are these big detectors that basically study the collisions. And one of these 4 detectors is called LHCb. So LHC, Large Hadron Collider, and B stands for beauty, which is the name of one of the 6 quarks. So there are these fundamental particles called quarks. So there are 6 of them in nature. 2 of them make up the nucleus of the atom, so the stuff that we're made of, basically. There are 4 others, and the beauty quark is the 5th heaviest, and it's like very exotic. It doesn't exist in nature normally, but we can make them in large quantities in these collisions at the LHC. And my experiment's job basically is to study these particles in great detail. And the reason this is interesting is that, in short, basically, the way these beauty quarks behave, in particular, like when you create one of these things, it only lives for about 1.5 trillionths of a second before it decays into other particles. And because they're very heavy, these beauty quarks can decay in lots and lots of different ways. And by looking at these different decay processes, you can learn about the fundamental forces that govern the universe, because the way these decays happen is basically via the fundamental forces that we know about. And the basic game we play is we measure the behavior of these particles, and we compare to the predictions of our current best theory of particle physics, something called the Standard Model. And we're looking for places where our experiment disagrees with the theory, because it's where you have these disagreements that you can get a clue to something new that you haven't seen before. So, for example, if there was a 5th force, some new force in nature that we'd not seen before that affected how these beauty quarks behave, and we could see some evidence of that in the measurements that we make at LHCb. So that's what the experiment does, and I'm part of a team. It's about 1,700 people now, I think, working on LHCb. So it's a big international project that has people from all over the world, including Ukraine. So the institute in Kharkiv is a member of LHCb and is involved in the experiment. There may be other, I can't remember if there may be even other Ukrainian institutes involved. So all of the 4 LHC experiments are big international projects. And I think that's also one of the things that makes CERN, beyond the science, that makes it inspiring, is that it's bringing people from different countries, different cultures together to work on scientific questions for peaceful purposes. So it's curiosity driven research. It's not about making bombs or weapons or or even particularly anything that you can really use. It's about understanding the world we live in.
And what I love, the LHC itself is like this a huge device, and it just like never stops to amaze me every time I learn something about it. Like just the sheer complexity of it, and the fact, like you're saying, that it's all very international, such a huge international project, and the fact that we've been able to to build something like this, just incredible. And also one of the things that also blows my mind is so we have this time dilation effect, right? And so when these protons get slammed into each other, I read that this tunnel, which is like 27 kilometers in circumference, right, in diameter, like to the protons, because that distance shrinks by a huge factor, to the protons, it's like 4 meters or so, because they're moving like very, very close to the speed of light, and the from that perspective, distances shrinks, and just it was just amazing for me when I read that, and it's I was curious, does it also give you that sense of amazement, when you for example go there, go there underground, and just that sense of oh my gosh, how how we've been able to build such a device, I don't know if how you feel about it.
Yeah, I mean, the engineering at CERN is amazing. So I first visited CERN in 2007. So, God, like getting on for 20 years ago now, which is a bit scary. Don't know how that happened. When they were building the Large Hadron Collider. So I was a student and I was on the CERN summer student program. So basically, it's like students from all over Europe come together at CERN and spend like a couple of months working on a little research project as part of usually one of the experiments there. And we went to visit one of the big detectors that was being built at the time. So it's called CMS, the Compact Muon Solenoid Experiment, which I was involved in when I was out there. I remember we went into this massive warehouse above ground on the other side of the ring, so out in the French countryside, and you had these huge slices. The detector is basically like a barrel shape, like a barrel on its side. And it was basically assembled by, imagine like vertical slices out of that barrel. They're like slid along down a shaft and then assembled, and they were all lined up on the surface, ready to be put into the experiment. These things are enormous. They're like 15 meters high, look like there's something out of Stargate, kind of crazy. And so that was kind of inspiring, seeing all of that. And that was so 2007, it was a year before the LHC switched on for the first time. And we were already then at the kind of end of a very long road. Like the LHC was first discussed seriously as a potential project in the late 1970s. And then it was approved in the 90s, or the funding was got together, and then this process of assembly construction. So you're talking about like decades of work to make this thing a reality. So when I turned up as a student, I was really there at the end of this very long process and seeing it all come together. And it was, when they switched the LHC on for the first time, there was this tremendous feeling of excitement, I think, because all that work, thousands of different people from all over the world doing their particular job, and it all comes together and it works, it's kind of miraculous, really, I think, in some ways. As you say, it's this incredibly complicated endeavor involving a huge range of different sorts of, engineers, physicists, computer scientists, and all of it has to work. And it does, and it's delivered amazing science for a decade and a half now, and will hopefully carry on doing so for another decade or more. So, yeah, I mean, I find that, I think the science aside, that kind of shared human endeavor and the fact that we can achieve these incredible things when we work together, that is incredibly inspiring. And I think it's a large part of what makes international particle physics valuable, is that, kind of joint achievement and effort.
But don't you feel like, when you said that we're doing these experiments basically for no reason other than like just trying to learn more about the fundamental, the nature of matter and so on. But for example, as I know, quantum mechanics, when it was just being developed, like those people, they couldn't imagine that like 50, 70 years later, it would basically yield all the amazing, incredible technology, that like we benefit from today. So like. Do you imagine that some of these discoveries might actually, like in the future, give us some, or like yield some, also some amazing technology? Because it seems to me like just when you just fund this like curiosity-driven research, right, and you let just smart people think about these things, like then. Somewhere along the way, someone comes up with some like amazing technology that improves our lives. Maybe I don't know how you feel about it.
Yeah. I mean, it's possible for sure, and like you get quantum mechanics as a good example of that. I mean, another example, maybe sort of in some ways even more dramatic, is nuclear energy. So when the atom was first split using an early particle accelerator in Cambridge in 1932. And this was when Ernest Rutherford was in charge of the Cavendish laboratory. And in this experiment, basically what they did was they split lithium nuclei in two by firing protons at them. And they found that when they did this, energy was released. And it was the first time that Einstein's famous equation, E equals mc squared, was demonstrated. Basically, you could turn matter into energy and you could release energy from the nucleus. And a journalist asked Rutherford, like at the press conference or at some interview, after the discovery, are we now going to be able to get energy out of the nucleus? Is like nuclear energy going to transform the world? And Rutherford, who was like the leader of the field, he discovered the nucleus, led the subject for decades, said, no, you're never going to get energy out of the nucleus. This is like moonshine. Forget about it. And, a decade and a half later, you have atom bombs, you have nuclear reactors. So the people who are at the forefront of the science often cannot foresee the impact of their own work. So with CERN, it's, there are two different sorts of technologies that can emerge. There's the direct application of the knowledge itself. I'll come back to that. But there's also there's the spin-offs. So when you build a gigantic experiment like the LHC, you're forced to develop all kinds of new technologies in order to solve problems that previously were not solvable. So an example of this is like one very famous example, the World Wide Web, which was developed by Tim Berners-Lee at CERN in the 1990s. That was basically put together as a way for scientists to share information across a network. And that was given away for nothing to the world. So it was not, CERN didn't retain any IP on the World Wide Web. That's one example. Another is the way that these accelerators work is they use very powerful electromagnets to steer the particles around. And these use materials called superconductors. And particle physics historically has always been pushing the limits of the sort of strength of superconducting magnets that you can make. And that has led to developments in MRI machines in hospitals, cancer therapy machines. So, it's a similar argument with the space program that, when one of the benefits of the Apollo missions was developing technologies for the space program that then had applications on Earth. I think the ballpoint pen is a famous, if not that inspiring one. So that's those kinds of arguments. Then, and also, when you build these massive projects, you're investing in the high tech sectors of the countries that are building them. So there's a kind of Keynesian economic argument that you're supporting your high tech sector. But then there's the question, okay, will the knowledge we discover at these experiments have an application? And that is much harder to answer. And I think with the major discovery of the LHC is the Higgs boson, which is the particle that's involved in the process that gives mass to the fundamental particles that we're made of. Can we use the Higgs boson for something? Well, it's very difficult at the moment to see how it could be useful. But what we're doing at CERN is we're trying to find out what are the basic building blocks of our universe, what are the laws that govern the universe, and so by knowing those things, you're in a better position to come up with some groundbreaking technology than not understanding. But as to could you apply it? I mean, some people have suggested, I was at a talk a couple of years ago, 2023 in London, where people were discussing a successor to the LHC, so the next big accelerator. And like, what are the arguments that you can make for this from a sort of applications point of view? And one really like wacky sci-fi idea that a serious scientist said, in the future this may be possible, is this idea of something called a sphalorizer, which basically uses the Higgs field in a very, very like particular way to generate energy. Now, like scientifically, it's possible, but like the technology is way, way beyond what we can do right now. But you can think of things like that maybe one day we'll use the Higgs boson in some amazing way to fly spacecraft across the universe or generate huge amounts of energy. But for now, it's really, we're acquiring the knowledge, and it may take years, decades, maybe even centuries to figure out how you actually apply it.
What's like, one mystery from your field, particle physics that you'd love to see solved, in your lifetime? It could be maybe like the nature of dark matter, or anything else, or it's also something that you can actually imagine making progress on. Not just you wish we would solve it, but where you think we could actually make some headway in terms of understanding.
I mean, dark matter is exciting for sure, and I would obviously love to know. A lot of people would love to know what dark matter is, but I think that it could be a rather uninteresting answer. It could just be there's an extra particle that doesn't interact with light, and we just add it onto our current list of particles, and that would be cool because we know what a lot of the universe is made from, but it wouldn't change things in a big way, I don't think, in terms of how we think about the world. necessarily, and because everyone sort of already thinks that dark matter is a particle, right? So it would just be like, well, what's the mass of this particle? The thing that would be more interesting, I think, would be discovering. So we have this theory in particle physics that's called the Standard Model, and there are 17 particles in the Standard Model, and we don't know why they exist. So we have this like list of particles. Now, there are certain symmetries that relate them to each other. Like there are 6 quarks, 6 leptons, which leptons are things like the electron and the neutrinos. They have these repeating patterns in their properties, a bit like the periodic table of the elements that Mendeleev wrote down in the 19th century. And the periodic table of the elements, the patterns in that table were clues to the fact that atoms had substructure, and ultimately those patterns come from the way that electrons arrange themselves around different atoms. That's where those chemical properties come from. So in the Standard Model, we're looking at a similar sort of thing, much smaller periodic table, but we don't understand where those patterns come from. And I think what I would really like to know, there's this sense that the Standard Model is like a partial picture of some deeper, more symmetrical theory. And what I would like to know is what is that larger theory that the Standard Model is a corner of? And discovering dark matter could give us a clue to that, because that would add an extra piece to the picture. It's a little bit like we've got a puzzle and we filled in one corner and we're kind of seeing that there's a sort of element of symmetry in it, but we can't see the whole picture yet. And by filling in some more of the gaps, maybe we'll be able to start to go, stand back and say, right, we can now see that this kind of arbitrary list of particles and forces actually comes from a much more deeper, more elegant structure. And that's sort of what I would be most excited about, because that would really be a big shift in how we think about the world, rather than just adding another particle to the list of things that we know about.
But let me just say, I don't know if you feel the same way, but the Standard Model is like such a boring name for the most successful theory like in all of science. I wish somebody would have come up with a better like term.
Yeah, it's a pretty uninspiring name.
Yeah,
it's true. Yeah.
But I should say, like, from reading your latest book, right, Space Oddities, I got the sense that first of all, again, like many of us have this misconception that that science was all done like by men 200 years ago, and there is like no more mysteries left. I certainly felt that way, like I was talking when I was in school, and like it didn't seem to me like a thing worth doing, because but now I understand that there is just so many more mysteries yet to be solved, and just and also like another thing that also just amazes me is that in science you love being surprised, right? For example, when we discovered the Higgs boson, like again, like the headlines were like, it's just this amazing discovery. We've been waiting for it for years, but I heard scientists saying that we almost didn't want it to be discovered, because that would mean that like there's like something else, and and maybe some like new paradigm of like physics, and it's just amazing for me, because in real life we've like most of the time we want to be right, and we want to feel like our ideas are like proved and so on. But in science it feels like you're entering this like very different world, and very like but it's also valuable, because you try to prove yourself right, but most of the time you want to prove yourself wrong, and because that's, like you said, where progress lies, and like where like new surprises might come up. And I don't know if you maybe can elaborate on that.
Yeah, no, I think that's right. I mean, okay, if you're a theorist and you've come up with some theory of the universe, I guess you want your ideas to be confirmed. But if you're an experimentalist, what you really want to do is find something unexpected, because it's the unexpected thing that teaches you the most, the thing that doesn't fit your worldview. And I sort of think about the way the world is going at the moment, and it's very different to the way we think in politics, where people have these very set ideas about their view of the way the world is, and anything that doesn't conform to that prejudice is ignored or dismissed. And science is the opposite. It's, being open. It's about being open-minded. It's about challenging your prejudices or your priors, and looking at new evidence and thinking about how could my view of the world be revised or improved or changed. And so no, that's absolutely right. We like nothing more than unexpected, surprising results, and often it's those unexpected measurements or observations that teach us the most. Like a very good example of this, which I talk about in Space Oddities, is an experiment that was done in the 1960s in America. So this was a radio astronomy experiment by two American astronomers called Arno Penzias and Robert Wilson, and they were working with a big radio antenna in New Jersey, just across the way from New York. And so imagine this big metal horn-shaped instrument in a field, and they're looking at the sky in radio waves, and they discover this really irritating noise in their receiver. Like it's kind of this like low-level microwave noise. And they can't figure out what this is. They think maybe it's stray radio broadcasts from New York, so they point the antenna at New York, but it doesn't get any louder. They think eventually they climb inside the antenna and discover that pigeons have taken up roost in the antenna. And they think, oh, maybe the noise is caused by the pigeon dropping. So they evict the pigeons, clean up their crap, but the noise persists. And eventually it's realized that this noise is not what just seemed to be some irritating quirk of the experiment was actually radiation left over from the Big Bang. And what they had found was the clinching evidence that really proved that the universe began with this awesome expansion of space and time 13.8 billion years ago. And that came from this kind of very small, strange thing they couldn't quite figure out. And so in science, we're always looking for those sorts of unexpected observations that might open up a new view of the world.
Yeah, and it's also like you make this very point in the latest book and it's again like one of the misconceptions that we have, as like the general public, is that we often think that progress in science is made by those like people like Einstein, like sitting, alone like in the middle of the night and like coming up with some amazing new idea. But it's most of the time like experiments lead the way, and even like anomalies, like like you already discussed in the book, like these strange things that we couldn't quite explain with our current theories. And like I also love those like examples from history, like having to do with the orbit of planet Mercury, right? There was like this discrepancy in the Mercury's orbit, and Newton's theory couldn't quite explain what was going on. And also I also read somewhere like when it comes to quantum mechanics, there was also like the so-called like black body radiation, right? And ultraviolet catastrophe, I guess that's what is called. And those people like trying to solve that problem couldn't imagine that it would yield a completely like new paradigm of physics, obviously. And just amazing for me, like because again like goes against that view that many might have, that it's all just like obviously every once in a while we have people like Einstein coming up with some amazing ideas, but he was like deeply guided by experiments himself, right? So
yeah,
maybe you can
I mean, science is about the world as we find it. So theorists can only come up with ideas based on the evidence that we've already observed. So Einstein's theories didn't come out of nowhere. They came out of a scientific context which involved many observations and experiments that were hinting at the ideas that he proposed. Now, Einstein was a particularly brilliant example of a theorist who managed to sort of leap ahead of where most other people were, and kind of pull these incredible ideas almost out of thin air, it seemed. But that is very rarely how science happens. And most of the time, it is this, experiment-driven, head down in the data, trying to understand what's going on in the world. And the theorizing, then kind of follows on from that and may propose new things that experiments go on and investigate. So there's this kind of symbiotic relationship between the two. But yeah, I mean, as you say, it's one of the things I try to sort of balance a bit in the book is, these narratives of like lone geniuses alone in the patent office or wherever coming up with these deep truths about the universe. That's a very romantic idea, and it's appealing. And perhaps the reality of experimental science, which is a lot of trial and error with bits of equipment and wires and glass and gases in a lab going on for years and years and years to try to understand some phenomena. It's less glamorous. It's maybe less it doesn't make such a good story, but that is how, the majority of science is done. And so it's trying to kind of balance out these like heroic narratives of theory with the kind of the experimental reality, I suppose.
I've heard people say, when they speak of the standard model of particle physics, that it's both like very beautiful, as a theory, but also quite ugly, because in like the following sense that you got all this, a lot of parameters that you don't really have an explanation for, right? You just assume that it has to be this way, and so do you find it also like perplexing about this like whole model, or do you think that maybe that maybe there's like some new physics now like waiting to be discovered, or do you think that maybe like we'll fix now a bunch of things and then like it all will like work together very beautifully,
Yeah. I think the standard model in some ways is underappreciated. If people say, oh, it's ugly, it's got all these particles and these parameters, we don't really understand it. But there are, if you speak to theorists who really, really think about the standard model and quantum field theory, they'll point out certain features of the theory that are quite sort of striking. So, for example, like one of the things that seems really arbitrary in the standard model is that the matter particles, so the quarks and the leptons, come in what we call 3 generations. So the first generation is the stuff that the universe that we can see around us is made of. So it's like the electron and the up and the down quark are in the first generation. And that's what makes up the atoms in our body. Then there's a second generation, which have copies of those first generation particles, but heavier. And then another generation, the third generation, which is even heavier. And we don't know why these 3 generations exist. It's a real mystery. But one of the things you can show is that if you want to be able to have, there's this mystery in cosmology, which is that there is, in particle physics, there is a symmetry between particles and antiparticles, so like matter and antimatter. And in the Big Bang in cosmology, if you use the standard model, you get this prediction that basically you should have equal amounts of matter and antimatter produced, and then they would annihilate, and you end up with a universe with nothing in it. So the fact that we exist is a big mystery. And one of the things that has to happen in order for there to end up more matter in the universe than antimatter, you have to have a violation of the symmetry between matter and antimatter. And this symmetry can only be broken if there are at least 3 generations of matter. So it seems like the standard model, we still don't really know why those 3 generations are there, but we know that if there were not 3 generations, if there were fewer, there could not be matter-antimatter asymmetry, and therefore there wouldn't be anything in the universe. So it seems that these things that look random or strange, actually they're linked to why the universe is the way it is in quite a deep way. So, but as you say, nonetheless, there are still these, as I said earlier, there are these features. It's like we're seeing the edge of some bigger picture. And I think a lot of people still hope that we will get the clues that will simplify the standard model and will reveal that actually all these things that seem arbitrary are actually have a deeper explanation. Yeah. But we'll see if we get there.
But do you think that, for example, the famous neutrino problem, do you think that it might be a clue to new physics? Because I've also read that because we can't quite explain why these neutrinos have this like tiny mass, right? And and do you think that it might lead us to like some new theory?
Yeah, I mean, it may do. I mean, you don't necessarily need new physics to explain the mass of neutrinos, but it is very strange that they're so small compared to the other particles. So, and the neutrino sector is still not that well understood. We don't really know the relationships in the masses between the different neutrinos, We don't know yet really whether neutrinos break matter-antimatter asymmetry. We know the quarks do, but we don't know about neutrinos. So there's lots to learn. And yeah, maybe that's one area where new physics may emerge, or it may emerge from the Higgs boson. It may emerge from beauty quarks. It may emerge from somewhere completely unexpected. It's quite hard to say in advance, but that's why we have to experimentally kind of cover all our bases. We need experiments that look at all of these things to allow us to continue to make progress, because you never really know when the next discovery is gonna come.
And I'm sure you're aware of Richard Dawkins, right? So, the famous biologist, right? And I bring him up because, well, for me, abuse science as like this question to better understand who we are and how we like fit into like the larger picture of reality. And I put it in the same category, as like art, music, and even religion, in the sense that for me this whole attempts to gain some insight into like the human condition and into like and how we like respond to nature. And there's like this tendency, and I don't know if you could say like anything about this, but like people like Dawkins, the willingness to like completely dismiss any positive value from a religion because it like clearly doesn't accurately describe our world, and science does a much better job. But for me, it can serve like many other purposes, and lots of people benefit from it. Like as a kind of maybe spiritual guide, or like to better understand like your inner self. I don't know like what you make of religion, but maybe you can speak to that.
Yeah, I mean, I think Dawkins has a particular view of religion and science. I don't think that religion and science necessarily address the same issues. They do to some extent. I mean, to the extent that certain types of religion have very dogmatic views about the origin of the world and the way things are. Issues like evolution, for example. In large parts of like Christian America, people do not believe in evolution by natural selection, even though the overwhelming evidence says that this is indeed how life evolves and propagates. And so I think that as a scientist, when religion comes up against established scientific ideas in a way that is harmful to people's understanding of the world, and not just their understanding of the world, but also can have practical negative consequences, like, for example, forbidding contraception, which leads to the spread of sexually transmitted diseases, or saying that you can't take blood transfusions, or vaccines are bad, or whatever you want to choose. These are kind of areas where I think it's legitimate for scientists to say, well, actually, these views are harmful, and this is not what's supported by the evidence. But that's a particular way of looking at issues between science and religion. I mean, personally, I don't personally believe in anything beyond what we can sort of see and understand in the world. I don't have a particular religious faith, but I can see that for many people, it serves an important role in their lives in terms of giving a sense of meaning, or beyond even the belief. I think probably the biggest benefit of religion is the community that you gain from it, and it's something that I think So for several years in London, I've spoken at an event called Sunday Assembly, which was set up more than 10 years ago now by a couple of comedians who had been brought up Christian, but didn't believe anymore. But they missed the kind of getting together with a community on the weekend, the role that church played in kind of shared traditions and festivals and charity and all these other things, and trying to kind of replicate that for a non-religious world. Like in Britain particularly, we're very, it's one of the least religious countries I think in the world now. But that does come with, you do lose things. Like churches were these like social hubs historically, and the fact that people don't go to church anymore means they lose contact with their community. So there's lots of roles for religion, and I don't think that science and religion are necessarily in conflict with each other. Although there are these areas where, when religion starts to say things about this is how the world came to be, or this is the way that medicine works, then, well, I would say listen to scientists, not a priest.
And do you enjoy, going out and being in nature every now and then? Because, for me, I come from the countryside area. I've been living in the countryside, for most of my life. That's where like I grew up and was born. And I do love whenever I have the chance, to, for example, go out at night and just look up, and if it happens to be like a clear, dark sky, and I can see at least hundreds, of stars. Just like for me, it gives me like that feeling of calm and connection, like that I don't really experience any other way. I mean, like, I could watch, like fabulous documentary, or like read one of your amazing books, or books by any other like writer, but there's like, for me, nothing like that. Visceral experience, like seeing, the night sky like full of stars, and I was wondering, if you maybe had some experiences like of nature that have stayed with you, and maybe like, or maybe made you rethink certain things, or like change the way you look at things. Maybe you had a chance to visit one of those observatories. Like there are many now where you get to see like truly the Milky Way, in all its majesty. I know.
Yeah.
Yeah.
Yeah, and I think, I suppose that's what, coming back to your point about religion and science, one of the things that science does give you, I think, is this sense of awe and wonder at nature and at the universe. And that can be experienced through just learning about science, but also through, direct contact with nature. And, I spend a lot of time walking in the Scottish mountains, for example. I really enjoy being out in nature, and that kind of sense of space that it gives you. I mean, in terms of, I've definitely had moments. One particular moment comes to mind when I was in Australia probably about 10 years ago for a conference, and I was driving along a road on the coast near Melbourne, and it was very, very dark night. And I got out, I stopped the car by the sort of beach, basically in the middle of the night, and got out and had a look at the sky. And it was, it was one of the most incredible things I'd ever seen, because living in London, there's a lot of light. You can't really see very much. You might be lucky to see Orion, in the winter, but otherwise you can't see much. But in the southern hemisphere, on a really dark night, you've got the whole band of the Milky Way. You've got the core. You can see like the core of the Milky Way, these big clouds of dust and gas that go around it, and the small and large Magellanic Clouds. You have this real sense of looking at this kind of 3D thing in the sky, and it really was, kind of awe-inspiring. And actually, I felt slightly dizzy like looking at it. I remember I had to like grab hold of the roof of the car to steady myself, because almost sort of this feeling of vertigo looking at this thing. So for sure, I think, nature has a tremendous power to create that sense of awe and wonder. And that is ultimately, where the scientific instinct comes from. Actually, going back to the religion thing again, like one of the scientists I talk about in my first book is Joseph Priestley, who was an English chemist who did work on the chemical elements. And he was a Quaker, and Quakers were a particular type of Christian in the England particularly, but possibly also elsewhere in Europe. And they viewed studying nature as a form of worship of God. Like basically the idea that by trying to understand the world, you are trying to understand God's creation. So there was this real sense that like by being out in nature, walking the hills, studying weather patterns, studying plants and animals, or looking at the sky, you weren't just understanding the world, you were also it was a form of worship as well. So those things I think are linked, those instincts, I suppose, towards like spirituality and this awe at nature, they're connected in some ways.
And well, I love. I hope you'll be able to see, this image, right?
Oh, the pale blue
Which is
dot.
yeah, exactly. I love bringing up this image because it's for me like science is ultimately about perspective, that it gives you, and like there is perhaps no better example of it than this image, and obviously the like beautiful description of that Carl Sagan gave us, when he was he was describing this picture, and for me as someone like coming from Ukraine, I try and return to it every now and then, because it does give me a sense of solace, and I just kind of say to myself, whenever I hear this, like obviously very terrible news now, and in regards, to the like, well, I'm sure we have this um, like ever-growing conflict with the new U.S. administration, and things that don't seem to be going well for us. And just whenever I hear or read this kinds of news, I just say to myself, like, this too shall pass, and that things will essentially get better, and well, at least I hope so. And just I think because of this perspective that I've gained, through like learning about these things, learning about science, and like being exposed to stuff that you've written, and like this kind of pale dot image, it allows me to to take that bigger picture, and just psychologically speaking, even it does help me. So I feel like that's also one of the perhaps values and beauties of science, that at hard times like this, it can be like very useful for you in a way that you might not have even like realized before. But
yeah.
Yeah,
I mean, I think there's two things there, isn't there? Which is that when you look at that image of the Earth as what Sagan calls a mote of dust suspended in a sunbeam, you have the sense of this tiny world in this huge universe, and all the things that we worry about and fight over are so trivial and irrelevant, really, in the scale of the universe. But on the other hand, there's also this message that the incredible preciousness of the world we have, and how fragile it is, and we have this duty to protect it and take care of it, and we're not doing a very good job of that at the moment. So I mean, I often think it would be brilliant if we could take Vladimir Putin and Donald Trump and Xi Jinping and Netanyahu and put them on a rocket and take them up into the universe and show them how small their countries are and how irrelevant they are, and maybe they would rethink the way that they approach the world. But maybe we just don't bring them back to the Earth. But it's it is. I mean, I think it is a source of solace, but it also has this message that it may be that this little rock is the only place in a vast universe where atoms have got together in a way that allow them to think about the universe that they live in. And if that's true, we've got a huge responsibility to not fuck things up, basically. And I hope that we can get that message out, and that the world will turn again. But yeah, it is, I think, it's definitely a source of solace. And
I also feel like there are two ways to look at it. One is, like you said, that we're so small and like seemingly insignificant. When you just look, take a look at this picture. But the other is like, we took this picture. Like we did it, and like that itself, it's can be like is a sense of pride that that we've been able to do it. So like that's like that itself for me is an amazing achievement. So like, because it was like from I guess 6 billion kilometers away or so. It was taken by one of the Voyagers, and just incredible.
Yeah.
And,
so human beings can do incredible things. They can also do terrible things, and you have to hope that our better instincts win out in the end.
Like any books that you've been reading lately, that you might recommend? Like could be fiction, non-fiction. I don't know, like if you're into one or the other, but maybe like anything that you've been just enjoying, that that you think would be worth like people's time.
So my brother for Christmas last year gave me a collection of Chinese science fiction books, which was called Broken Stars, which I really enjoyed dipping in and out of. I'm quite a big science fiction fan. I mean, I don't read as much of it as I used to when I was younger. I used to read quite a lot of Arthur C. Clarke and that kind of thing. Trying to think what else. I should read more popular science, but I don't really. I think because I write it and spend so much time thinking about it, is kind of in a way the last thing I want to look at when I Actually, I'll tell you one thing I'm looking forward to, and it's a bit of a it's kind of a kid's book, I suppose, in a way. But I'm a big Philip Pullman fan. So Philip Pullman, who wrote a series of books called His Dark Materials, which is about this. It's basically about these two children who go on this amazing adventure and they end up killing God. That's kind of the the punchline. But it's all about, it's some about some of the themes we talked about. It's about science, it's about religion, it's about authority and tyranny, and it's about freedom. And Philip Pullman actually, he's written this follow-up trilogy of books called The Book of Dust, and we're waiting eagerly for the last one to come out. So hopefully that will be, I think it's going to be out in the next year or two. So that's something I'm very much looking forward to.
I'm reading currently, like, hope you'll be able to see.
Oh yeah,
yes,
Stephen
Stephen
Hawking.
Hawking. Yeah, and it's a biography of him by Kitty Ferguson, who you might have heard of. Yeah, it's she's an English a science writer, and she's written a lot about a lot about the lives of famous scientists in the past. And like, what's lovely about this particular book is that she actually well she actually visited and spent quite a bit of time, like personally with Hawking, like visited him in his office at Cambridge or in his house, and it's just full of lovely and very like relatable accounts and stories of his life. So yeah, I could recommend you to take a look at it.
Thank
I don't know if you read biographies at all, but yeah, it's
Okay,
a good
thank you.
one. And
I'll have a look.
yeah, and also I love the what Sean Carroll, who you might know as well, what he has come up with, and also Brian Cox, who I mentioned as well, and Brian Greene also, and he does this like World Science Festival, where it's in the US and Australia, I guess. This live performances, it's very nice, and like one of the final questions that I want to ask you is, do you think that this ultimate search, this quest to like figure out, like discover those building blocks of the universe, do you think that it's like a never-ending quest, or do you think that we would come, at some point we would come to an end where we would go like, and that's the way it is, and just there is nothing more fundamental than this. Just curious, just a fun question, because obviously it would be impossible to give like a precise answer, but maybe let's just
I really don't know. I mean, part of me hopes there is no final answer, because in some ways it would be a shame if we had finished the journey and there was nothing new to learn. I mean, Steven Weinberg, who's one of the sort of architects of the standard model of particle physics, wrote this very short, beautiful book in the early 90s called Dreams of a Final Theory, which talks about this idea of the search for the ultimate theory of the universe. And he makes the case that such a theory may exist and that it may be out there. But I think we're a very long way away from that. There's so much we still don't understand. So maybe one day, I mean, I think one of the things that you can see happening in physics is that every step now takes more and more effort and energy and resources. So we've solved a lot of the easy stuff, like the low-hanging fruit, Newton's apple, for example, literally low-hanging fruit. But we're now in an era, physics is a very mature subject. So to make new discoveries, we need bigger experiments and bigger telescopes and more advanced technology, and it becomes ever more and more difficult to push the boundaries of knowledge forward, and it takes longer and longer periods of time. And so but hopefully, the big leaps forward tend to happen when we come up with some new way of looking at the world. So like when Galileo first looked through his telescope at the heavens, that transformed very quickly our understanding of the universe. And so we're always looking for, what's the next instrument? What's the next way of seeing that will change the way we understand the world? And I think gravitational waves potentially are a way that we are learning a lot very quickly. But as to whether we'll ever get to the end, maybe. But even if we do come up with the sort of final fundamental theory, there will still be a huge amount we don't understand, because just because you understand the fundamental theory doesn't mean you understand complexity in the universe. And actually, if you want to understand something as complicated as, say, the human brain, particle physics is absolutely useless. Like, the brain is far too large an object, far too complicated to treat it as a collection of subatomic particles. So, maybe we'll get to the final theory, but we'll still always have a lot to learn, I think.
What for you maybe like the most what's for you the most mind-blowing fact about the universe? If you could like pick any, like something that or maybe some kind of observation or something that like never stops to blow your mind. Maybe,
I mean,
or
I
it could
think
be
the
few.
thing, I think the thing that I just find extraordinary is the fact that we can think about the universe and that we are made of atoms, and those atoms behave under dumb physical laws that are very simple. You can write them down on a piece of paper, and somehow, from that incredible simplicity, you get thinking, feeling beings that can wander about the universe. And I think that is deeply mysterious and strange. And there's no reason to think that that should be possible, right? If you code up a very simple game with little balls bouncing around in space, you would not expect a living being to emerge from that, albeit over billions of years. But I think that is very surprising and extraordinary and mysterious. So I probably pick that. The fact that, I think, was it for what Feynman called atoms of consciousness, the fact that atoms can think about atoms is very strange.
Yeah, or like what Carl Sagan said, like we're a way for the universe to know itself. Also
Yeah, yeah.
also a lovely quote. I mean, it's it's also interesting. Like you mentioned, gravitational waves, right? And I love that story that I I read about it somewhere. But the history behind this discovery, like there was there were like these two black holes, like 1.3 billion light years away, from us, and they were like spiraling into each other, and then and then merged into one, and there was like this huge explosion, and lots of energy went out, and it, uh, it always happened while on this planet, on planet Earth, there were like there was still like single-celled organisms, like single-celled life, but because it was like 1.3 billion years ago. But then as that wave has traveled across like the universe, and then as it was entering the Milky Way galaxy, it was like 100 like thousand years ago or something. When and then like 100 years ago, it was like we had Einstein coming up with this theory, and then just like two light years away, they turn on like the newly refined version of this like LIGO detector, and like 2 days later, that wave like rolls by and passes one of the and yeah, the detectors in like Louisiana and in Washington D.C. Just which is an amazing story, like and also like one of the beauties of science is like because we can like you said, we can experience it, and we can like somehow the knowledge that we have of what we're made of doesn't make it any less miraculous or whatever. Just makes
Mhm.
it more beautiful, I guess. And
Yeah.
the well, also like for me, one of the beauties of science, and like you mentioned this already several times, is like this the sense of unity. There is so much unity in science. Like Einstein himself was looking for this like so-called unified theory, that would unify all of like forces, and like in biology, in the study of life, there is so much unity because like we all come from a common ancestor, right? We all share DNA with like the rest of life, and I love that sense of unity because it's like it transcends all this like national and like religious divisions that we as a society often have, and just yeah, feels to me like in science you're entering this like very different world, and one that I think we as human beings would be very happy to live in. If we could all if science could be like the basis of our of our government, and or that I know that's like a very utopian view, but still. I'm at least happy that we have this like aspect of our lives, called science, where you know, like once you enter it, yeah, it's just very international, and without borders, and you're just all working towards a common goal, and which is like to better understand nature and our like place in it, and yeah, it's just
Well, yeah.
a
I mean,
beautiful enterprise for me. Yeah, yeah.
I wouldn't want to ruin the romance, but I suppose I should also say that, science does have conflict as well, right? Scientists are human beings and they argue and they fight over things and there's disputes. And I suppose the thing about science, though, is because of the process, because of the method, it progresses. So all of those debates and arguments that happen, ultimately they lead towards a better understanding, because science is this rigorous process of testing, theorizing, testing. And so on the whole, yeah, it unifies it. And it is an international community, but we shouldn't pretend that scientists aren't also bad-tempered and can be, greedy and jealous and have all those other human emotions that, are part of the human condition.
Yeah, but I love that, like you said, that science can transcend that, that like many of those biases that we have, and all those, because you might like so deeply believe in your own idea, but if like experiment shows you that it's wrong, you have to just like throw it out. And I
Yeah.
love that science as an enterprise can can do that. And I I also I'd love to ask well, like here in Ukraine, we've been dealing with this Russian invasion of, like for more than 3 years now. It's been like such a long time, and it's like so much terrible stuff has happened already, and to us it seems like there is that things are going to get even worse. Like I was talking about with the new like U.S. administration, and it's there's just this ever growing sense of uncertainty, that many of us could feel, and it might be like very easy to just lose any kind of hope and like give up, in the midst of it. And I'd be happy to hear if if you have maybe any advice, or like what message would you like to give to Ukrainians on how to like remain hopeful in the midst of all this, uh, and maybe have to especially when things get so difficult, and you're just overwhelmed with frustration, and feel like giving up, or have to just keep going. Maybe you can offer some words of wisdom. I know it's like difficult because you don't live in that environment, but I'm sure like you're following the news, and it's I know it's like it's very important for you, because like you said this in your email, that you think about it every day. So maybe you you can share some messages that we could
Yeah.
pass. Maybe.
I mean, I can't imagine what it's like to live in Ukraine at the moment and live with this constant fear of the future and this threat. So it's very hard for me to give any wisdom. I'm sure there's much more wisdom in Ukraine than I can offer. But I mean, all I would say is I think when you look at the world I think is with you, like, or at least, the Europe, I think most people in Europe are very supportive of what is happening. And I just hope that the Western Europeans can get their act together and actually, do what needs to be done to hold Russia back and help, Ukraine protect its sovereignty and its people. But I think also if you, I don't know, mate, I don't know if this is comforting or not, but if you look in the sweep of history, I think about my grandfather. He was born at a time where the country that he was supposed to be a citizen of didn't exist, and he lived through a period where he saw his country reemerge and be independent and then be reoccupied and dominated by the Soviet Union. And he died at a time where Poland was not free and it was, part of this kind of communist bloc. But, 20 years after he died, freedom, Poland managed to throw off communism and become free again. And, you go through these periods of darkness, but I think in the end, like history tells us that these are temporary and they don't last ultimately. And that may not be very comforting if you're in the middle of it. And I could imagine, the idea of waiting 20 years or something for an ordeal to be over may not fill you with much hope. But there's, I think it's in The Great Dictator that Charlie Chaplin, he sort of says that there's this basic fact that all men die. So even tyrants die. And eventually, the people perpetrating these crimes will die, and hopefully wiser people will replace them, and the world will change. But, I have no particular wisdom to share. I've never been through anything that, like what you were going through. And I just wish you, all the very best. And I hope that things improve. And I hope that through continuing to sort of think about other things, perhaps to think about, science and the sort of the enjoyment and the pleasure that it can bring some sort of distraction and some solace from what must be a very difficult day to day.
Yeah, no, that's a beautiful message, actually. And we'll hope that he will die soon, like, but the final question that I want to ask you is, I've always been, and I'm sure this is the case with you, I've always been into these like big questions, as long as I remember, I always been curious about like why are we here, and like what's the point of all this like this big like philosophical questions that just this they're always in the back of my mind. And I want to ask, like, there's many things in life that can bring you a sense of meaning and purpose. For some it could be like art, music, writing, like poetry, whatever. For others, like could be science, learning about the universe, like learning about something that you're that you're curious about. And so when you like think about your life and think of all the things that you've done, that you've contributed like to the general public, and the like up until now, and all the like interactions you've had with people and like your family, what would you say, like what gives you the greatest sense of happiness and meaning, even if you, or it could be several sources of meaning, you don't have to pick one, but I'd love to to hear like what life means to you, personally.
Wow, only the easy questions today. I mean, I've been very lucky in my career that I've been able to pursue things that I'm interested in, and I wouldn't necessarily say that I've particularly achieved a huge amount, really, in the grand scheme of things. Like, I'm quite proud of some of the. I'm quite proud of some of the books. Well, particularly the first book, I'm quite proud of that. I think it's quite good. The second book's good as well, but I think the first book's better. So that gives me some satisfaction, and it's nice when you hear from people who've, taken something positive from what you've done, or they've enjoyed something you've done. So that definitely gives you a sense of hope and meaning and optimism, and kind of drives you on to carry on doing what you're doing. So it's very. I feel very fortunate to be able to share my enjoyment of science with others and to see their enjoyment in return. That gives a real feeling of pleasure and of purpose, I think. But other than, I think, the most important things in my life really are my interactions with like my friends and family. And, I just had a daughter a month ago, and seeing the effect that she's had on my parents and my partner's parents and our families, and the way it's brought everyone together. I think, fundamentally, those are it's those interactions, the sort of love you have for your family and friends, that gives meaning to life. And I think we can find that no matter what's going on in the world, I hope. So yeah, but I think it's a combination of things. It's that satisfaction from hopefully doing a job that you take some pleasure from. Um, but I don't pretend that I'm achieving anything particularly substantial there. But I'm very fortunate to do something, as I say, that I enjoy. But I think ultimately it comes down to it. It's, your relationships with others that really matter.
And I love. I guess it was Carl Sagan who said that like if you're in love, you want to tell the world, and he then goes on and like say to say that if you're in love with science, you obviously want to tell everyone about it. So I feel like that's been like the case for you, yeah. Like because you're not just passionate about doing it, but yeah, you want to share it with others. That sense of
Yeah.
excitement and wonder, and it's yeah. It's well, it's been so much fun to get to talk to you. I look forward to it for like quite a long time, and but very
Well,
glad
thank
that
you.
it's finally worked out. And yeah,
Yeah. Well, it's a real
thank you
pleasure
so
to talk
much.
to you, and best of luck with all your future projects.
Yeah, yeah, and I hope that um, hopefully that once this war is over, then I could visit your country. I've never been to England, and yeah, we could. We could meet and have a beer and talk about some of these
Absolutely.
ideas.
Well, yeah. Let me know if you ever make it to the UK.
Yeah,
Let's definitely grab a
yeah,
beer, and I'll show you around Cambridge. And I
yeah,
hope to come to your country too at some point in
yeah.
the future.